Hi everyone, this is my first Capstone project. It's a data visualization project, and I have used the popular electric vehicle dataset from the state of Washington for this project. The first step was to import the required libraries from Pandas, NumPy, as well as Bokeh and Matplotlib, and then I imported the dataset which I had previously downloaded from the website, and I just did a high level check of what the data looked like, and we can see the columns, the first two rows and the columns. The next thing I went to do is to just look through the columns to see if there were null values, and I could see that the counts of each of the columns were different, and I went ahead to use this to print the function, sorry, to print out the nulls for each column, and I was able to see that this had quite a number of null values. So what I did was to drop off null values in two major columns, and that kind of catered for the rest. And after dropping the nulls, I ended up with no null values. The next step was to do so feature exploration and feature engineering. I did that by examining some of the categorical variables. The first column I checked was the state column, which literally had no unique, had just one unique value. So I dropped this column off, and then I checked for the county, and I decided to create a new column called location, which was basically from the county as well as the city. And then at the end of that, the length of that was about 511 different locations. The next thing I did was to kind of do like an understand. I wanted to check if the location had been added, and I can see it's been added here to the data frame. And then I also converted some of the columns that were floats, had float data type, to integers for easy analysis later. And I also checked for unique values across some of the columns that I would be using much later for my visuals. And then I also decided to extract the latitude and longitude values from the vehicle location column, and I used that using a simple function, and then I added those newly created columns to the dataset, which you can see here, latitude and longitude just beside the location. And finally, I decided to create an electric range um, category based off the electric range column, and I just wanted to categorize the electric range in four different groups, again for easy um, analysis and visuals much later. And finally, we'd have this is what the data set looks like on a high level, with the location, latitude, longitude, and electric range categories. And I did a describe just to understand, to see if there was anything different or any outliers in the data set. But it looks good so far. The model year, the mean is 97, the max is 2024, and yeah. And I did this so that I could understand how to create the different ranges that I later used, especially the minimum and maximum values that I later used for some of my visuals. Up next is the first visual, which is just the distribution of the electric vehicles in the dataset. And what I use Bokeh for this one, and you can see that overall Tesla has the highest distribution with 49.7%, and followed closely by Nissan, and yeah, this is just for the top 12. And then I went ahead to also do another visual to look at the trend of the electric vehicles over the years, and I could see that from 97 up until 2010 nothing really was happening, but then there were new electric vehicles from 2010, a small spike here in 2019, and a major spike here in 2023, with over about almost 60,000 vehicles in 2023. And yeah, the next thing I wanted to do was to understand, for each of the locations that I created, what are the top locations with most of the electric vehicles. I used a pie chart for this one, And I also specified the percentage distribution. We have King Seattle with 34.6%, King Bellevue with 10.5%, and I, as well as some others. This is just the top 12 locations again. And then I went ahead to create a bar chart um, is for to show the models, the car models for the different car makes, and using Matplotlib, and I was able to see again that Model Y and Model 3 of Tesla were like the top. Took the highest distributions, and we have again this Model Leaf for Nissan coming next, um, and this is just again for the top 12. And then I decided to do like to check what this electric category electric vehicle type column looked like. And what I did was to create a simple black bar plot for this, and then I can quickly see that this is based off one of the newly created columns. And one thing I realized is that the hybrid vehicles had were all within the short category. So basically the hybrid vehicles had all of them fell under the short electric electric vehicle electric range category, and the rest of the electric vehicle types were distributed across the other categories. And then I also created a stacked bar chart to check for the electric vehicle distribution and the CAF eligibility. So this is what that distribution looked like for both battery electric vehicles and hybrid electric vehicles. And then I decided to create a correlation matrix to understand the relationship between some of the numeric features in case of further analysis. I use Matplotlib for this one, and I was able to realize that from this correlation matrix, model year is highly correlated with vehicle ID, and electric range is also highly correlated with base MSRP. This was just for me to understand the data set. And finally, I decided to create geomaps based off the latitude and longitude columns that I previously created. And I used Bokeh for this. And this is what my map looked like. And and this is just latitude and longitude points from the data set. If you mouse over like any of the points, you can see that if you mouse over any of the points, you would see that if on this for the single point we have Chevrolet so for each point depict it shows the location of a car. So one of them, this shows that this car is in Roosevelt, the car make is Chevrolet, and the car type is battery. It's a battery electric vehicle. And this is another one in Patterson, it's a Nissan. It's also a battery electric vehicle. So that is the end of my project. Thank you very much.